Hello, everybody. I welcome you to the Airlock Microgateway webinar. My name is Stefan Dietiker, and I'm the product manager. If you have questions during the webinar, please feel free to write them in the chat. I will have an eye on that and try to pick up the questions you have and to answer. At the end of the presentation, we still have time to get into your questions you might have, and otherwise just send me an email if you have questions later on. During the next 45 minutes, I'd like to walk you through how we think that nowadays security should be accomplished for web applications, especially in the modern development lifecycle with the DevOps 8. So one thing is about the tooling. So this is number one of the topics. What is to be considered besides the tooling? I want to dive into that as well. And the third and main part of this presentation is Microgateway 4.0, the new release we are going to announce this week. And last but not least, there is a demo. So not only slides I'm presenting today, but also how Microgateway 4.0 does work, and it gives you the opportunity to use the environment as well and also already play around with it if you want. So let's start. How should you secure your web application? If you look at the DevOps 8, there are many possible tools or methodologies you should apply to secure your web application. There is no silver bullet. So it is not you just do SCA and everything is fine. You need to do more than one of these tools to apply to your DevOps 8 in order to secure your web application. I want to show you how you can secure your application with the web application firewall. So how we fit into that DevOps 8 and how we can increase the security for your applications. If we look from other perspective, what are basically the goals of a security team? The security team wants to mitigate the number of vulnerabilities that are deployed in production. Nevertheless, it is always or vulnerabilities in production, but you want to filter them and to ensure that they are not abused. You want to authenticate the users and ensure that only valid users can access your application. And last but not least, many of you might have regulatory or compliance requirements that must be met. So these are the goals from security team which should be accomplished. How can that be done? In general, you're building business logic. So that means to get the best out of it, the business logic should fit hand in hand with the security. How does that work? You do have your web application, which you are building with the business logic. In there, you have to configure or to program some part of filtering, so input validation, attack prevention, throttling, and access control like authentication, authorization, password reset, and so on. But I assume that you do not have only one web application, but many. So this means that you need to do the same protection mechanism for each application again and again. And what if every web application is written in a different programming language? You need to write the exact same protection for each web application from scratch and you cannot reuse what you already have built. This is why we think that it does make sense to have the filtering and the authentication mechanisms outside the web application, where a component can concentrate on this part and give you great possibility and great security. So this means the devs can focus on this logic and do not need to create security filters, authentication methods. They can simply just create their business logic, and you can use the same security tools for any web application in your company. It is language agnostic. You can establish a security policy which is enforced company-wide, and you do have many features out of the box. So, but what about the application-specific policies? We all know that every application needs its own policies, and usually the global policies are maintained by a different team than the app team. So if there is a single component between our clients and the web application where all these kind of policies are maintained, it might be a little bit difficult to configure this component in the center. This is why it does make sense to push this kind of application-specific policies close to the web application, bundle it together with the microgateway, and roll it out. This way, the centralized edge gateway can be used to enforce some kind of global policies, while it's still possible to have the fine-grained specific configuration very close to the application. Test it from the developer stage and roll it out to the production smoothly. This means the devs do not need to reinvent the wheel. You can use the same security mechanisms for every web application. And if you want, you can connect an IAM to the edge gateway and ensure that only authenticated users can access your web application. What does this mean for quick releases? The security team can still define company-wide policies on the edge gateway. We will see later on that it is also possible to define some kind of policies for the microgateway itself. So it can enforce specific settings that should be used in the microgateway, and they can observe the active configuration. So what does have the app team configured? And on the other hand, the app team can write the specific settings and roll out the web application smoothly. So there is no obstacle anymore to roll out new releases from security perspective. That sounds all good, but is there something which must be considered? Yes. So in general, it doesn't matter what kind of tool you pick. It is a cultural adoption. So this means every people must stand behind, pull together. So the devs, the ops, security, and last but not least, the management. If they don't believe into how they should work together to have this DevSecOps life cycle in place, it doesn't work, no matter which tool you choose. Security should be integrated from the start, and we will see security itself. So the policies, they are distributed, controlled across multiple teams. That might change also the responsibilities and what kind of work the different teams might accomplish. And to get the best out of it, it should fit hand in hand. So DevSecOps means for the developers that they must be empowered. So they must have education, how to configure, how to use the microgateways. They must have guidelines provided from the security teams, blueprints and templates, how they should use the microgateway, and in order to integrate it to the web application. On the other hand, the security team, their focus shifts a little bit more in direction of consulting the project teams, maintaining the deliveries I just mentioned before, observe the configuration of the microgateway, so what exactly has been configured by the teams, and prohibit insecure settings with policy tools like Kyverno, OPA Gatekeeper, or KubeWarden. And last but not least, monitor the production and track new attack surfaces. Let's now jump into the news. So what's about Airlock Microgateway 4.0? It's not released, so not yet available. It is expected by end of May, and if no obstacle come across, it will be this week. Microgateway 4.0 is a Kubernetes native integration. It does provide security for API and web applications. It is Envoy-based proxy. From a very simplified architecture point of view, we do have a Kubernetes cluster with a pod and the web application container. This web application needs to be secured. So the Airlock Microgateway runs as a sidecar of this web application. It lets the good users in and keeps the bad stuff out. From a feature perspective, it is Envoy-based. We do have Kubernetes native integration, which means we have an operator and our custom resource definitions. So that means the operator takes care of injecting this sidecar into the pod. We do hot reload, so this means if the custom resource files change, we do reconfigure the sidecar, so without a new rollout. We support deployment with or without Istio, and we still have the community edition with all features available. And in comparison to the Microgateway 3.3, we have a small memory footprint. The features we have in are HTTP 1.1 and HTTP 2 support, and TLS for downstream connections. Downstream means for front side. We allow to configure native Envoy HTTP filters like Lua, AWT, X offset. So this is more or less the comparison to Apache expert settings we had in Gateway or Microgateway 3.3. We have DenyRules, limits, and HeaderRewrites. HeaderRewrites is request actions based on headers and also response actions based on headers. We will see another slide exactly for this feature. We parse JSON, and we have telemetry support for logging and metrics. Let's jump into the configuration, how it looks like. As mentioned, we are sidecar of a web application. So the main configuration file is SidecarGateway. It references by using the pod selector what kind of pods should be secured and what configuration should be applied to. So what you see here is which port should be secured, 8443, and what settings of the content security ref should be applied to. And in general, some TLS settings or Envoy HTTP filters that can be used. Header rewrites is the configuration to say what kind of headers are allowed or should be removed or added to the request or response. As mentioned before, it is in fact the request action or response action you might be familiar with from the gateway. And obviously we have the DenyRules. You can configure globally the security level for the DenyRules, the threat handling mode, override for certain DenyRules, the security level, configure your exceptions you might have for certain parameters on the HTTP methods and for which DenyRules it applies. Last but not least, it is also possible to configure custom DenyRules as well. We also have limits in Microgateway 4.0, which can be applied to general parameters, to JSON documents, or to requests in general. Please note that the body size is quite low. In comparison to Gateway or Microgateway 3.3, this setting is only applied to the parsed bodies. So it should be possible to have a very, very low setting here. So please only increase it if required. And do not just copy paste the setting you have from the gateway to the Microgateway 4.0. So besides the features we have built, there are many more benefits you have from the Kubernetes native integration. It allows you to configure policies. So for example, to disallow log-only mode in DenyRule. So security is distributed, so which means the teams can configure their microgateway, but the security team can still enforce certain settings to be allowed, to be enforced, or disallow. It also gives the security team the possibility to see in the productive cluster by using kubectl what kind of settings are used. Or use templating with Customize, Helm chart, or other very famous tools in Kubernetes to template the configuration. As you saw, the configuration is declarative, so it means security as code. You could put it in Git under version control. You can audit, diff the configuration and can use it together with GitOps tool like Argo CD. But that's not enough. Thanks to great plugins for Visual Studio Code or other IDEs, and the fact that we have custom resource definitions, you do have completion, validation, and tooltip during configuration. So how great is that? That the developers are supported by their IDE to create the proper configuration. We also updated our manual. So on the left-hand side, we have a picture of our documentation, which gives insights about the architecture, the concept, and the use cases. And on the right-hand side, the API reference, which describes the CRDs we have, we provide, what are the default values, and what must be configured at least, or will be configured if you do not set a certain setting. It is very helpful to get started from the beginning. You might ask yourself why we have chosen Envoy. Envoy is the de facto standard for Kubernetes data plane. This is what Gartner says. And it allows cloud-native architectures. It supports modern web protocols like HTTP3 or gRPC, and it is extensible with Lua script, which gives you great flexibility. And last but not least, the license which Envoy has does fit for our business. If you come from Microgateway 3.3, how should you accomplish the migration? So in general, the migration is breaking. We do have Kubernetes native integration right now, so it requires a Kubernetes distribution. The configuration format is different. So now we have these custom resource files and previously this config YAML file. The proxy is different as well. So now we do have the Envoy and previously the Apache and Security Gatekeeper. So it means that there could be some differences from the behavior as well. So how should you migrate from Microgateway 3.3? We suggest that you reintegrate your web application. Use the old configuration file as a reference. Configure the allowed request response headers in HeaderRewrites and start with the old DenyRule configuration. So like the security level and DenyRule exceptions. There is an exception for the limits. So please start with the new default values from the limits and only increase it if required. And keep in mind that the limit for body size is only applied to parsed bodies, not to uploaded files. Let's jump into licensing. This is a high-level overview of the features we have in Microgateway 4.0. You see that we still have the Community Edition, which can be used for free. In general, the Community Edition has all features. This is something we have changed from the previous Microgateway version. The previous Microgateway version has only a few features in blocking mode. All the others were in log-only mode. Now in Microgateway 4.0, all features are available in blocking mode. But there are more restrictive operational parameters. So like the throughput or the number of sidecars, so how many pods you can secure, the license expiration, or which version you can use. And the support is also only from the community forum. The Community Edition itself is intended for small environments or local developments. The Community Edition has this forum I just mentioned before, which is available under this URL. It requires you to register to questioning and commenting. We are moderating this forum, but what we don't do is case analysis or guaranteed response times. We do point you to documentation and best practices, but for complex cases, it requires premium support. In general, you need a license. No matter whether you want to run the premium edition or the community edition, you need a license. There are the two links how you can grab a license. You just need to fill out the corresponding form. For the community edition, you get an email within a minute with the license attached. And for the premium license, we will get in contact with you to send you a quote. Important to note is that there is no built-in license anymore. In Microgateway 3.3, the community edition was already built in. Enough slides. Let's jump into the demo and let's see how Microgateway 4.0 does behave. I try to copy and paste this link so that you can try it also if you want to. The start time for the environment is about 3 minutes. The link itself works until 31st of May at 6 p.m. I already did that before in order to reduce the time we need. It is a track where you can learn, where you can get familiar with Airlock Microgateway. First, we want to see what is installed with Airlock Microgateway 4.0. We want to attack an unprotected demo web application. Next step would be to protect the demo web application, inspect the modifications we have done to protect our demo web application, and then send again the attack string to the protected demo web application. Let's start the track. What we see on the top is a shell where we can access a Kubernetes node and apply some commands. We do have a demo web application here, which is a very, very simple echo server, which only shows us the request part and allows us to send some query parameters. And a link into the documentation if you need to access the documentation for certain settings. Airlock Microgateway is already deployed. So let's have a look what exactly is deployed in our Kubernetes cluster. Let's check first the namespaces which are in our Kubernetes cluster. And we see here we do have an Airlock Microgateway system namespace created when we deployed the Airlock Microgateway. Within this namespace, we do have 3 deployments. The operator I just mentioned, the one which configures the sidecars, and for licensing, we do have these 2 deployments, the license guard and the Redis, which stores information for the license guard. The configuration is done through custom resources. So this means we do have deployed many custom resource definition files, which allows you to configure those custom resources. This gives you just an idea about the custom resource definition files being deployed. Let's get to the next step. Now we want to attack the unprotected demo web application and see that the attack string reaches the application. This is an example for an attack string we can send in a query parameter. I'm now going to copy and paste this attack string and send it to the application. Right now, there is no vulnerability in the application, so we don't see something magic. But what we see is the request, it does send the attack string, And we can double check it in the logs as well. And we will see the log of the web application does tell us that the attack string has reached the web application. So there is no protection in place. So let's change that. Let's protect our demo web application. For that purpose, we want to configure the microgateway to secure this application. There are a few files provided. Let's have a look what is inside these files. We see which has a pod selector with matches label app kubernetes.io name demo web app. And the configuration is applied to container port 8080, and this is the content security ref which is referenced. We do see that we have a pod running, and this pod has exactly this label applied. The content security ref is referenced by the sidecar gateway and thus refer to the DenyRule security settings. And the custom resource DenyRules simply configures the security level strict and threat handling mode to block. So let's apply these three files. The demo web application is not yet secured by just applying these files. We need to instruct the operator to inject the sidecar. We see the pod has still 1 out of 1 container running. Let's patch the deployment and instruct the operator to inject the sidecar. And what we see is a rollover of the pod, and we will see that now the pod is coming up with 2 containers out of 2, so which means the sidecar is injected. Alternatively, you can run the commands over here just to ensure that the deployment is up and running. Let's now inspect what has changed to our pod. As we saw previously, our pod is in running state. It does have 2 out of 2 containers. Previously, it was just 1 out of 1. And let's have a look into the pod itself, what has been changed. We see we have injected an init container, the Airlock Microgateway Network Manager. We have as a container the demo web application. And as a sidecar, we have the Airlock Microgateway engine, which filters all the incoming traffic. And the readiness gates tell us that the application itself is ready. So let's now attack the protected demo web app and see what happens. We will send now the same attack string as before. And we see that the request is blocked. What does the logs tell us from the demo web application? We see that a request to echo has been done. This was when I was opening the web application itself, but the attack string is not received by the demo web application. We can have a look into the logs, which is structured. So the logs from the Airlock Microgateway, and in here we see that the DenyRules matched. It was security level strict, the rule SQL applied, and the parameter was A with the attack string over here. The second command only shows the block log messages. The first command shows us also allowed log messages. But the one we are interested here is the one which blocks the traffic. So that's the end of the demo. I enjoyed it. I hope you too. As mentioned, you can use the link and try it out on your own. Let's have an outlook on Airlock Microgateway 4.0. As mentioned, we are going to release, hopefully by end of this month, Airlock Microgateway 4.0. So let's talk about the upcoming release 4.1. We do have planned to create the CNI plugin for Airlock Microgateway, so which means that you do not need additional privileges for the Airlock Microgateway network manager in order to reroute the traffic. So you can just run your application with the privileges it has. We will allow multi-namespace support, so you can instruct the operator to just watch certain namespaces. It will have also allow rules in it that you can configure what kind of traffic should be allowed or not. Possible other features which might come in an upcoming release are listed on the right-hand side. Ideas are many. We are just looking from release to release, what should we put inside. If you have questions, feel free to ask them. I will be available and have a look into the chat, whether you have questions or not. Meanwhile, it was a pleasure. I'd like to thank you. And yeah, if you have questions later on, you can also send me an email or just try it out, the community edition, or have a look into our documentation. Thank you.